So the next presentation, the last one, was a bit of a teaser. We looked to, in the last, I don't know, half year, a bit more than half year, it's actually about a year now, all this generative AI popped up everywhere on the internet and on all the conference and presentations. So we wanted to also have something about it, and Sidharth is exploring that path, was exploring that path, so we invited him to have a presentation about generative AI and openEHR.
Okay. So this image is generated by AI. And the prompt was, I always think this to be true, which is as a doctor, in your lifetime, you might spend time with maybe 10,000 patients, 100,000 patients. And today we've seen really good presentations just from the beginning till the end about technology and how technology can change healthcare. And I actually believe that you write one line of code that can probably affect and save the lives of millions, whereas as a doctor, you're limited to the number of people who you treat and see. So collectively, I think this room probably has potential to save more lives than a group of doctors of the same capacity. Now, yeah, technical issue. Okay. Just a quick raise of hands. How many of you have used ChatGPT? Okay, keep your hands up if you've used ChatGPT programmatically. Not bad, okay. Oh, no. Wait. Shouldn't have touched this. And how many of you have used, other LLMs apart from ChatGPT, like Llama, Vicuna? Okay. So quite a bit. Which company are you from?
From NetApp.
NetApp. Copilot. Okay. Got it?
Yeah.
Okay. Will this work?
It has to work.
So in this talk, we initially thought that we'll show a few cool demos, but then decided against it, and we are just going to show you techniques and tools that we can actually use for you to get the results that you actually want. Okay, so it's mostly going to be a technical deep dive into how you can get these results yourself. And yeah, no, this doesn't work. Okay. Thank you. Okay, so this is something that we built in 24 hours. We are talking, there's no audio, but as we are speaking, it listens to a transcript of both of the people speaking. I was the doctor and he was the patient, and both of us are actually practitioners. And as you're talking, it gets the transcript, it detects the potential diagnosis with a certainty percentage and suggested questions to ask, all live, okay? And this is something you can build in 4 hours today. It's not a big deal, right? This is something that all of you can do if you just know a few tools and techniques. And I just want to talk to you about these tools and techniques so that you can go back and you can try this out yourself. So this, again, like it's a video out there. There is an open source repository. And I'm still bitter about the fact that this one got more stars than Medblocks UI. But still, that's the AI hype train that we are on right now. So I'm going to talk about a few use cases first. And I think these use cases have a disproportionate result if you implement them properly in your system. Okay, use case number 1, structured data capture. Can you take unstructured clinical information and can you convert that into structured data? So example, let's say you have unstructured text. Patient came with complaints of fever and cough for 2 days. On examination, pulse was this, temperature was that. Can you now convert this into, can you detect the correct archetypes? Can you detect what needs to be put where? For example, and also note that fever and cough have been coded with the correct SNOMED CT terms. And again, like the rate of the heart and the correct units, structured data capture, okay? Second use case, clinical decision support. Can you have a policy, and Rong has been talking about GDL, and there was a question about have you explored ChatGPT-like interfaces. This is a very, very interesting use case. Can you have a policy and can you have structured data and then output alerts and output actions according to this data, right? So I've always thought that as medical students, they just dump you with a ton of information, right? There is learning the fundamentals and learning how to actually administer certain tests. And then after that, 80% of what you learn is just, okay, this is the thing, you need to do that, and so on. And I actually think with these kind of models becoming more and more mainstream and faster and more accurate, we will get to a point where pushing information into a brain of a human is not the most efficient way to deliver care. And for example, let's say you have a policy that states that all prescribed medication should be checked against the patient's allergies to make sure that the medication does not contain any substances that the patient is allergic to. Right now, this may be obvious, but this is a policy in itself, right? And there may be multiple policies like this that you want to define, that you want your practitioners to define. It may differ based on organization. And can you take that policy, and can you take data, for example, the patient has, let's say, adverse reaction to penicillin, and the drug being prescribed right now is fortified procaine penicillin. And can you output a decision saying this is not safe, and the reason is because patient is allergic to this, which is a type of penicillin, right? This is the second use case. Third use case, queries and question answering. This is like the most obvious one. I think most of you would have thought about this, which is, can you ask it questions on your data? How many patients had fever in the past 2 months? And you answer that, you give them a graph chart, if possible, give them something else to show. So now we have a few issues, and I will talk to you about a few secret techniques that you can use to actually make these things work. I know most of you here have not tried out ChatGPT programmatically, but it's just one step away, right? Like if you know how to use ChatGPT in the browser, I really recommend that you try out a framework like LangChain or Llama Index and just make things work, okay? So most of that will make sense when you go back and try this out. So I have 4 secret techniques, and I'll tell you when to use this, how to use this. And the main issues today is like hallucination, right? Like if the model or if the AI model does not know something, it just makes things up. It's almost like a student, but I think PhD students problem. And it only works well on the training data set. So if you have a particular data set that you train it on, it will work very well on that. And then the additional, if it doesn't know, it doesn't know, right? Then the last 2 points, I had made this slide a few weeks ago. The pace of progress here is so fast that this is not really an issue with a few of the advancements, especially MemGPT and so most of this. But if you're still using Llama, GPT-4, Vicuna, any of these models, then limited context window and limited memory is still an issue. So you'll still have to work with that. But I think this presentation will age very poorly. So what are these 4 secret techniques, and when and where can you use them? So I'm actually, there was this memo from Google saying that we have no moat, and neither does OpenAI. They are just admitting the fact that there is absolutely nothing that they can do to gain supremacy in the AI space, because the third competitor who's beating them is actually open source. And today, if you take a look at the progress, Llama 2 almost beats GPT-4 in specific coding tasks. And it's only going to be a few more generations until the best AI model that's available to us is open source. And these techniques can be applied with any model, not just OpenAI's GPT-4. Okay, and I'm going to reveal these secrets because I'm pretty sure my colleagues might have figured these secrets out yourself. I'm just going to make it public to everyone. So let's take the first example, unstructured data to structured data. So you say a patient came with complaints of fever and cough for 2 days. On examination, this is what it is. How can we prompt a model to convert this into structured information? Let me see if we have enough time, because anybody wants to try? And this is just, you just need basic understanding of ChatGPT. Anyone wants to try to answer how we can do this task? Yeah?
Well, finding commonalities with words
Yep.
that may have some translational issues. For example, in the Dutch healthcare system, using Dutch words for SNOMED, SNOMED words in English. That's
okay.
that we have been encountering, so that's why I mentioned it.
Okay. Got it. I mean, those issues are going to be there, right? Because I'll give you some examples of we have clients who work 24/7 just sitting there and digitizing records. They look at handwritings and they look at unstructured data and they convert it to structured data. This is an extremely big problem for us, spending millions on this. And how good is AI today at converting unstructured data to structured? It's able to recognize that this is paracetamol, and it's actually paracetamol. Okay, so it's this good today. And I think it will just be a few more generations before open source catches up. And as soon as open source catches up, all of you who are concerned about GDPR, I can't run my models I can't send my data to OpenAI, all that will go away. You'll be able to use open source models on-prem using your own GPUs. It's happening. These techniques will help you. It'll cut down a lot of time for you, and it'll save you some effort. So the first secret technique I want to introduce is prompt engineering, right? So how can you make a model return what you want? You give it examples of what you want. So for example, you start with something like this. And again, LLMs don't have any memory, okay? So you pass in an input, so you pass in something like a prompt, and you get back an output. That's it. So the way something like ChatGPT remembers all of your conversation is that every single time you ask it another question, it sends the entire conversation history back to OpenAI, and then that's how you get the next response. So this is an important concept to understand. So here we are just giving it some general instructions on the top, and here we are telling it unstructured text, pulse 89 per minute, and then you're passing in the JSON schema. So these models are ridiculously good at understanding JSON and JSON schemas because there is a lot of general training data out there. It's already been trained on all this, and it's really good at this. And now if you see here the description of the general, this schema, the rate of the pulse or heartbeat measured in beats per minute. Anyone knows where this is from? That's from the CKM. That description is the clinical knowledge manager's description of heart rate. And the more and more we look at CKM and the archetypes and the descriptions, the more it feels like this has been designed for AI all along. So it's almost like prompting on steroids, right? You just take the description on the CKM, you use it as is, it works really well. And you'll be surprised at how much data available in the CKM can just be used as is. Now, what you're doing here on the top is we're giving it an example. So we're giving it, so this is called one-shot training. So you're giving it a prompt, which is a one-shot example of what it can do, and then you're providing a template here. So again, here in the template, if you worked with LangChain or if you worked with these AI models programmatically, you might know that you're supposed to replace the text with the actual piece of text. You're supposed to replace the schema with the actual piece of schema, right? And the schema, especially with the openEHR simplified data formats, something that Better has been pioneering, it works extremely well, okay? So this is the first step. Now, take a look at this. Patient came with complaints of fever and cough. There's something special about fever and cough, right? We just don't want it to output, extract fever and cough. It's not of much use to us if it does that. We ideally want the SNOMED city codes. What technique can we use here? Any idea? okay? So there's something called retrieval augmented generation. Anyone? Okay, so what do you do? So LLMs are, again, only good at the training data that they're trained on. How likely is it that somebody has trained an LLM on the whole corpus of SNOMED CT? Unlikely, unless you're going to do that yourself. So what you instead do is, it's expensive to train models, it takes a lot of time. So instead of doing that, you do something called RAG, or retrieval augmented generation, in which as you are passing, the prompt again has changed slightly. So you're telling that there is unstructured data, there is a schema, but there is also this extra piece of information called relevant data. And we are asking it to look at this relevant data and then output the result. So here again, when we see sign and symptom, the name of the reported sign or symptom, comment, symptom name should be coded with the terminology where possible. Again, this is all from the CKM. I'm not kidding. It works really well for AI, somehow. And the relevant data, you need to get the code, the terminology, we've gotten this. So your question might be, how did you get this in the first place? How did you get a list of codes that are relevant? Again, you use traditional statistics, you use traditional models. There are these technologies called vector embeddings and vector databases. How many of you use vector databases? Okay. Okay. So it's something you definitely need to at least try out. And these are the vector databases available today. And most of these are, what it does is it takes all of your words, your normal English words, or it could be Dutch words, it could be Spanish words, it could be anything, right? So it could be any word, and it converts them into a vector encoding, okay? So this is what Google has done for matching search results. So how is a specific word similar to another word? So what you want to do is, given that full sentence, you want to be able to pull out words, or you want to be able to pull out codes which are relevant to that particular word, and not just in how they look, but in meaning. So what is happening here, whole thesis discussion, but if you are able to use something like a vector database along with a vector embedding like SBERT, or there is also normal BERT, there are a lot of other vector embeddings available to ADA. So it will give you a result of codes that are relevant to your sentence. Okay, so you can easily do that with these vector databases. And once you pull it out, then you pass it again to your model, right? You pass this again to your model. Now your model does not need to hallucinate. It has all the information that it needs, and it outputs cough with fever finding exactly, accurately. Okay, let's look at this. Patient came with complaints of fever and cough for 2 days. On examination, pulse was this, and temperature was 98 degree Fahrenheit. Now here, I want to introduce another tool that you can use. Are models like ChatGPT good at converting something like 98 degree Fahrenheit into Celsius? Is that a task that we should be giving large language models? No. And sometimes they are kind of okay if the numbers are small, but as soon as the numbers get really big and more complex, it breaks down. And LLMs are meant to process natural language. They are not meant to do arithmetic tasks. Do not make them do arithmetic tasks. Okay? So what you instead do here is you have another technique called function calling. Okay? So what you can do with function calling is, now again, it becomes more and more complex as we go, but you now have unstructured data, and now you also have a definition of functions, okay? So here it's a simple conversion. So what we are doing is there's a function called days ago to date. So in the text, you have the number of days ago that this patient has come with something. So fever and cough for 2 days. And you want to convert that to a date, because in the schema, you expect date of onset, right? So again, the onset of this episode for sign or symptom. So now to convert this particular 2 days ago into date, firstly, the model does not know when the record is dated, so your system will probably know that better. And secondly, they are not good at arithmetic operations to begin with. So what you do is you ask it to either output structured data or a function call. So in the first round that you run this, it will output something called days ago to date, bracket 2. This result is for you to process. You take this result, you run it on your traditional system. Okay, and this is again just an example. You can use this for all sorts of crazy things. You can use this to display widgets. You can use this to call another API. You can do whatever. You are prompting the model to call another function, and as soon as you execute this in your own environment and it gets the result back, you pass the result back to the model along with the initial prompt. You can say function called result is this, and then now it knows that it has all of this data needed, and then it immediately goes to the structured data. Okay? Clear? Any questions so far? Right? So, secret technique number 4. And this is again, like most of your use cases will be solved using just these 3 techniques. But if you want to go beyond what we have and the accuracy of what you are getting, you will also need to do some instruction fine-tuning. So this is again training the model and fine-tuning it on more data, especially question and answers, so that it knows when to call a function, it knows when to what kind of JSON to output, what specific domain knowledge to your application. And you can use this for training it on your own artifacts, for example. So your applications might have widgets, it might have forms, and so on. You can train the LLM on your specific thing. And the way you do that is you just have question and answers. You curate a set of question and answer. You ask your team to work on it. It doesn't need to be huge. It can just be as much as 50,000 possible. Like, I think 50,000 is a huge number, but it's not huge if you split it amongst a team of 10 and ask them to work on question and answers every day. So you give it question and answers. So this can be used, for example, to train it on things like AQL, right? Because it does not know how to execute AQL. And for example, I just asked the general ChatGPT to do AQL, but then I have to correct it, saying that, hey, that's not exactly the right AQL. Please do something like this instead. Now, this itself can be a prompt on the top. You can include this along with the prompt, and that will itself output accurate AQL. But if you're really serious about using LLMs in production, you want to do some sort of instruction fine-tuning and give it more examples, give it more complex use cases, and cover all the edge cases so it understands what it's working with. Yeah, so these are the 4 secret techniques, and if you read it up in papers, some people may call instruction fine-tuning QLoRa, and retrieval augmented generation, there is a prefix called RAG. And vector databases, you need to check it out, right? Like, because I think they are much better than the traditional way of querying for things. They work really well with context-based retrieval. So please do check out vector databases. And try these frameworks out. And LangChain is in Python, and it has a Node.js binding. Llama Index just is able to pull data from multiple sources. It's really good at doing that. Do try these out. And I can show a demo, but I'm not sure. OK, maybe if we have some time, we can see a demo as well. We are here. You can ask us any questions. I think demo time? 2-3 minutes? OK. Do you want to see a demo? OK. See, I don't have a fancy demo. I just have my Insomnia collection, and I have an example of how it will work with openAI's APIs. Okay. So this is a very simple demonstration of how, again, I told you about retrieval augmented generation, but I'll give you a very simple use case. So I'm going to, you can see the right screen, right? Okay. So I'm removing this particular thing off of my section. So first, what we have is the user gives a prompt saying, convert the following unstructured clinical text to structured form. Use the SnomeDCT API to query any terms that should be output in SnomeDCT with the appropriate constraints before outputting the form. we have the note. The patient had breathlessness, vitals was 100 degree Fahrenheit, 97 degree Fahrenheit, and pulse was 80 beats per minute. BP was 120 by 80. Now, what I'm using here is the openAI's function calling. So that's also pretty good at outputting JSON, but if you are using some other models like Llama to Vicuna, you can just not use function calling and just use the prompting mechanism I showed you earlier. So here you have two functions that we've defined. So one is called query SNOMED. So this function can be used to query the SNOMED CT API with relevant terms and lookups. And we have another function called form serialize. Use this to output the final structured data for the form. And here we are actually giving it an exact output schema. So we have the body temperature, we have any event, we have temperature, we have unit. And note that in unit we only have degrees Celsius, and we also have another called chief complaint. I'm connected to the internet, so let's see what happens if I send this. So OpenAI's API has gotten this data, and it's thinking. And now what it's telling me is, it is telling me that I do not know what to do yet, but I want to call this function called query SNOMED. Is this big enough for the back? Not really, okay. Is it better now? So what we're doing here is, this is step one. We are asking it, and we are giving it a bunch of functions to call. And here it has returned. And again, it took a lot of time, but this will get better over time. And things only get faster with computing. So in some time, it's returned telling us that it wants to query SNOMED CT. And it's also telling us what it wants to query using. It wants to query for breathlessness, and it wants to query using this particular SNOMED CT constraint. Okay, now this particular SNOMED code, or this constraint is dummy, but if you see here in the schema, we've mentioned that chief complaint should have this particular SNOMED CT constraint. So it used that. So while you are creating the openEHR template, you can easily see how you can constrain it to a specific terminology. Put that in the template, and you can ask the model to only restrict it to that particular constraint. Now, once we have this thing, what we need to do now is actually execute this function against our API. So it could be a vector data store, it could be a traditional FHIR terminology server, it could be anything. But once we have that, we return the results of that. So that is the result here. So I'm returning the results of this particular SNOMED CT search. I've searched for breathlessness, I have used this constraint, and I've gotten, let's assume that I've gotten all of these data points. Now what I'm doing is I'm giving it both of this. So it has this, and it also knows that the next message was this function call that actually got executed. So I'm executing that. Let's see what it gives us. And we got our final result. So it's telling us that the body temperature, any event temperature, magnitude, 37.7. So this is correct, but ideally you don't want to make ChatGPT do this. You want to use a function for it to actually convert the degrees, but it did convert it correctly. Like it did convert the 100 degree Fahrenheit and the 97 degrees Celsius into the correct Celsius. And the chief complaint, it got it right as well. This is the code for breathlessness, if I'm not wrong. It is the code for breathlessness that we've given. And it's gotten the systolic blood pressure. And again, we didn't say anything about systolic or diastolic. We just gave it the 120/80. It understood that this was systolic, 120, and this was diastolic, 80. And the pulse was 80. Did we give pulse in the... Okay, yeah, pulse, 80 BPM. Yeah. So right now you're seeing almost 100% accuracy of this particular unstructured to structured data thing. But there are edge cases. Obviously, when you try it out in production, you'll know that there are a lot of edge cases. And we are still working to make this better than the average human. It's going to take some time. But using those techniques, especially those 4 techniques, I hope you also get good results. So thank you.
Thank you, Sidharth. Questions?
Yep.
Well, thank you for the presentation. It was really interesting. I was wondering, how do you deal with privacy issues using this?
Yes. So either you can use the private openAI APIs, or you wait for the open source models to get better than GPT-4, which I think they will.
Yeah.
That's the bet that a lot of us are making. So once that's there, then you just need to run it in your own servers and your own systems, and all you need is a bunch of expensive GPUs.
Okay, so you don't feed your own data into the openAI.
Yes.
On-prem. Yeah.
Yes, you don't send it to OpenAI, you just run your own models on-prem.
Okay, thank you.
Yeah.
Okay, other questions? Okay, there. Doing my sports.
Sidharth, thank you for a very insightful presentation. I've just got a question. Well, you may be too young, but I remember having a map, driving a car, and just trying to find my directions with a bit of critical thinking. My kids would say, okay, just use Google Maps. But they probably would also drive into a river if Google Maps tells you so. So I'm asking is there any kind of, or do you fear that the critical thinking of doctors will become less with this kind of approach?
Very good question.
Non-technical.
My answer is that the models just have to get better than the median doctor. So if, again, very controversial takes. Is this being recorded?
Your father will see it.
Okay. But no, what I think is, you're right. Critical thinking is a part of a doctor's profession. But the more we can remove that component, I think the better. Because it's almost equivalent to, if you make protocols good enough that even the dumbest doctor can provide the best possible care for your patients, I would go to that system over one extremely overqualified doctor who's good. Again, he might be better or she might be better than the rest of the lot, but that's that one person. What about the median doctor? And what about the ones below him? Right. So, but again, I'm just talking about unstructured to structured data. I'm not. So it's like boring jobs, anyways.
Other questions? Okay, there one.
Just a little bit further on this last question, how to validate the outcome? That's always an interesting topic with AI, not? So you could say hallucination. So how are we sure that the openEHR archetypes are correct?
Yes.
Is it then? And there, you could say we have two answers. One is you must know the training set. And the training set defines whether or not it's the adequate outcome. So how to describe the power and the weakness of a specific trained AI algorithm? That's the first question. And the second is, some people say, oh, you just have to validate the AI algorithm with a golden standard with your father, for example. And when it's better than a doctor, then okay, we can trust it. What do you think? Which of those two methods will, in the end, validate medical AI routines?
Okay, so I'm going to take this question only from the context of unstructured data to structured data, just to avoid controversy. Okay, so let's say that these digitizers who are working day in and out to convert the data manually into structured data points, they have a particular accuracy and they have a particular outcome with that process that they are converting. So we usually also have people do it twice or thrice on the same data set. So multiple people, they do it multiple times just to make sure that the human digitizers are doing the correct job and they're actually converting it correctly. And you take that as the training set. technically, you don't need a training set for these kind of approaches. This is all zero-shot, unless you are doing instruction fine-tuning. Most of these are zero-shot problems. You don't need any training set. All you need is a testing set. So when you are testing it against this set, if the AI performs better than your median digitizer, it is by default better than humans in that particular task. So that's how we at least evaluate it. Again, there might be more academic, more rigorous ways of doing this. Yes.
Well, thank you. I think we have to finish because we also have to break. And then we have other presentation in this room. Thank you, Sidharth, for the presentation. I think it was quite insightful.